is 7.4, day 1. So we're going to have 2 days here. And this is kind of a big day because you're going to learn another new topic. There's several in this chapter. And we are going to, our learning target in this day is to learn how to evaluate logarithms. And so you haven't worked with logarithms before. Okay, so let's define what a logarithm is. And it's going to look like a strange definition, but it will get better as I show you how to use the definition. And these logarithms have a base, and so these are going to be logarithm of y with base b. Alright. So it's going to look like this. This is where the base goes. It's kind of like a subscript. It goes down. And then on the same level of log is the letter y, and this will equal x. This is what we call the logarithm form, and this is true if and only if. Do you remember that shortcut or shorthand that we used in geometry? That stands for if and only if b to the x equals y. And then this is just the exponential form that you're used to using in the last few sections. 7.1 and 7.2 and 7.3 we had the exponential function. The exponential function and the logarithm function are inverses of each other. So we've also been doing the inverse functions. So I'll talk about this a little bit more. You have two kinds. You have this where the base can be a different number, but you also have another one called the common log. And the common logarithm, and this is a logarithm with the base of 10. Now, we don't, when we use base 10, we just write the letters L-O-G, so you won't see a number down here. If you see L-O-G, you know it's the common logarithm and it has base 10. This is also a button on your calculator. And on your calculator, it just looks like L-O-G. But anytime you see, oops, I misspelled calculator again. I don't know why I like to do that, but let me fix it here. Alright. So there's another one that's on your calculator, and it's called the natural log. And this is a logarithm with base e. And you just learned about the number e.
This is the last call. If anyone has Final Four t-shirt orders, please come to the office
Then
right
on
away.
your calculator, this
Anybody
is just
that has Final
LN.
Four t-shirt orders needs to come
If you
to the
see
office
LN,
right
you
now.
know
Thank you.
that it has base e. And remember, e is just a number that's 2.71828, so it's a number very close to 3. Alright, you're going to use those later in the notes too. So the first thing that you're going to have to do is to move from a logarithm equation to an exponential equation. So the directions say rewrite the logarithmic equation has exponential equations? Okay, so you have your logarithmic form, and you have your exponential form. You'll get really good at this, and it's not hard to do. Okay, so these questions start out in the logarithmic form. So it looks, whoops, this is supposed to be a 2. Okay, so this is the logarithmic form, and you would read it like this: log base 2 of 32 equals 5. So the base here is 2. And if you go back up to the definition that we have up here, the 2 is the base. In both forms, it's called the base. And then what it equals right here is the exponent. And then the number right here tells you what it equals in the exponential form. Now, a lot of teachers that teach this have students do the arrows. So this is the base, this is the exponent, and this is what it equals. Okay? So that's really what a logarithm is. It's the exponent that makes this a true statement. So let's try another one. Okay, so what this is saying is 7 to the 0 power equals 1. Okay, 7 to the 0 power, base is 7, 0 is the exponent, this is what it equals. Okay, so this is saying 13 to the first power equals 13. This would be the exponential form. This is the base, this is the exponent, this is what it equals. Alright, so 1/2 is the base, -1 is the exponent, and remember negative exponents mean reciprocal, so that will flip and be just the number 2. 1/2 to the negative power of 1 equals 2. Okay, now you're going to have to use this to evaluate logarithms. Okay, so our next example will just say evaluate the logarithm. Okay, so the question will just say to answer, say what this equals. Okay, so it's always going to start like this. Okay, so what you're trying to do is say 3 to what power equals 81, and that's your answer. So 3 to what power equals 81. Okay, so you can, some of you know this and some of you will have to play around on your calculator, but 3 to the 4th power equals 81, so we know this, the answer to this logarithm is 4, because the answer is always the exponent that makes this number 81. Okay, let's try another one. So I want to know what power of 4 would give me 0.25. Or you could think of that as 1/4. That might be easier. 4 to the what power? That's where I'm putting a question mark. And I'm going to change this to 1/4. Okay? because 0.25 is the same as 1/4. So what power would make the 4 go down in the denominator? And that would be -1. It would make that 4 drop down. Okay, so this logarithm equals -1 because that's the exponent. One more. Now the base on this one is a fraction, 1/4. Okay. So what it wants to know is 1/4 to the what power would equal 256. Okay, so our base is 1/4. What would I raise it to? And it would equal 256. So again, I know it's going to be negative because it's going to make it do the reciprocal. And if I do 4 to the 4th power, it's 256. So I know this is going to be to the -4 to make it flip and do the reciprocal. Okay, so this would be -4. Okay, I have one more example here for how to evaluate. All right. So if I had log of 49, base 49 of 7. So I want to know 49 to what power, so I'm putting a question mark, would equal 7. And I know that if I took the square root of 49, it would be 7. So how do I convert the square root into a fraction? You've been doing this for a while. And the square root, remember, is the same thing as the 1/2 power. So that would mean the square root of 49. So I know that 49 to the 1/2 power equals 7. Okay, and then you'll have some easier problems on your homework too, where you're just going to use a calculator. And it'll say evaluate logarithms to 2 decimal places. So you might want to pause for a second and get out your calculators so you can find the right buttons. So if it just says LOG, that's a button on your calculator, and you're just going to enter it, LOG 51, and remember this is the common log with base 10. And if I round that to 2 decimal places, it would be 1.71. Alright, and then if you see LN, sometimes it's lowercase and sometimes it's uppercase. This is the natural log with base E, and they want you to evaluate ln of 5. And that would round to 1.61. Okay, that's the end of our first day of logarithms.